this video, we will go over the origins of gravitational and electric fields. So, now, the origin for a gravitational field is any object that has mass. So we can say that it's an object that has mass, that's m, and then the gravitational field lines will be directed towards that mass. The gravitational field lines start at infinity and they end on masses. So what this is saying is these are all of the screen comprises the gravitational field, which is a vector where it has direction, so the direction is towards this mass, and the magnitude from this pictorial drawing is how close the lines are together. So in here, where the lines are really close, the gravitational field will be much stronger than out here, where they're further apart. Now, we care about the gravitational field because if we were to put a second particle, say that this is M1, out here, the gravitational force on M1 will be equal to M1 times the gravitational field G. So I'll have that be in this color over here. So the idea is that this mass here, placed in the gravitational field created by this mass over here, the multiplication between the two gives the gravitational force, and now there's going to be a gravitational force that is also in this direction, that's Fg. So, one thing that we can point out is that this gravitational field, G, has to have units of newtons per kilogram, or force per mass. The idea is if we multiply the gravitational field by a mass, then we end up with a force. That's what we can also see here. And gravitational fields are always attractive, so masses always attract each other, they never repel each other. In contrast, we can have electric fields, which are produced by charges. So here we have plus q and minus q, and what we can do is we can draw the electric field. So electric fields start on positive charges or at infinity. So this would be an electric field line starting at infinity, and they end on negative charges, or this is them ending on negative charges, and then over here is them ending at infinity. And we can draw one in here. It goes from positive to negative. Like so. So, much in the same vein, we'll have an electric field E. So, we can make this more pedantic. That's a vector, and then this is also a vector. So if we put a third charge right here, and we'll have that be Q, then the force, let's say that's Q1, the force on Q1 is just the charge times the electric field. So much in the same way, we can say that the electric field E has units of newtons per coulomb, where coulomb is the unit for charge. So this is force per charge. So if you multiply an electric field by a charge Q, then you end up with units of force, and that's what we see going on here. So electric fields can be attractive or repulsive. So in this case, the positive charge and the negative charge are attracting each other. whereas if these were two positive charges, they would be repelling each other. So likes attract, or likes repel, opposites attract. Thank you very much.